Hey everyone, this is the first video to go along with section 17, which is on the zero product property. This all connects to how to solve quadratics when they are set equal to 0. So in order to figure this out, we need to know what the zero product property says. So if you see a product, which means multiplication, set equal to 0, what has to be true about any of these parts of the product? The only way to get 0 as an answer is if one of these was 0 to begin with, because we know that anything times 0 is 0. So the property says if a product, mn, whatever they are, equals 0, then either m had to be 0, or n had to be 0, or both of them were 0. But at least one of them had to be 0. So now let's see how that applies to what we've been learning. This has already been factored, okay? So here are three factors: x times 3x minus 15 times 5 plus 23x. And this has been set equal to 0. So I can use the zero product property to solve this, because either x has to be 0 or 3x minus 15 has to be 0, or 5 plus 23x has to be 0. But in order for this multiplication to equal 0, one of these things has to equal 0. So one of those solutions is already there, x is 0, okay? But now I have to solve these smaller equations. So do a little bit of algebra, add 15 to both sides for this one, and then divide by 3, and I get x equals 5. So there's another solution. Subtract 5 from both sides. So 23x equals negative 5. Divide by 23. This is not a nice number. It's going to stay a fraction, but this is one of my solutions. So this winds up having three solutions. X is 0, x is 5, or x is negative 5 over 23. And each of these answers will cause this to equal 0. So it'll balance out the equation, which is what I'm looking for. So this is what the zero product property says. But in order to use it, notice that you have to have a product. Why do you think we learned how to factor? Okay, so now we're going to see how our factoring skills will help us in solving our quadratic equations when they're set equal to 0. So let's do our first full example. I would like to find the x-intercepts of f of x equals negative 3x squared minus 9x plus 84. Well, let's zero in on what they're asking. They're asking for x-intercepts. What do we know about x-intercepts? We know that x-intercepts occur when y equals 0. They occur when the output equals 0. So isn't this asking me to solve 0 equals negative 3x squared minus 9x plus 84? That's really the hidden question here, is I want to be able to solve this equation. So I look at this and I go through all the steps of factoring. This is why we learned how to factor. So the first step is to factor out a GCF. The GCF here is going to be a negative 3. When I factor out a negative 3 from everything, it's going to give us an x squared, a positive 3x, and a negative 28. And remember, you can pause here to make sure that you did factor out the correct number with the correct sign. Okay, then we focus on the quadratic that's left in the parentheses. And I'm going to go through the whole quadratic process. I'm going to identify my A, B, and C, and I'm going to multiply AC. So in this case, my A is 1, and my C is negative 28. So I get negative 28. What multiplies to give me negative 28, but adds to give me 3? Okay, and this again might be the place where it takes the most time. You have to find that combination. So the combination for that will be a 7 and a negative 4. 7 times negative 4 will give me negative 28, and it'll add together to give me a positive 3. Okay, then I make my t-chart. My leading term, which is 1x squared or just x squared, goes on the top. My two numbers paired with x go on the bottom. I do some simplifying. And now I found my two factors. So now, with all of this work done in the meantime, I can now write this as 0 equals negative 3 times x plus 7 times x minus 4. But I'm not done, okay? All I had to do here was get the factors, but now I actually have to solve this. So we have another step now. Obviously, it doesn't make sense if we say negative 3 equals 0. So we don't have to worry about the coefficient that we took out. The only two things that we really care about are the ones that contain an x. So I need to see when x plus 7 equals 0 or when x minus 4 equals 0. So I solve each of these mini equations, and I wind up that x equals negative 7 is one possibility, and x equals 4 is another possibility. But always refer back to what they asked. This time they asked for x-intercepts. They weren't just asking for solutions. They were asking for points on the graph. So this is not even our final answer. Our final answer is going to be the ordered pair, negative 7, 0, and the ordered pair 4, 0, because they were asking for x-intercepts. So before you leave a problem, make sure that you have fully answered it. All this work is great, but the final answer needs to be written as ordered pairs because they were asking for x-intercepts. So that's our first example using the zero product property. All right, next example. X to the third minus 3x squared minus 28x equals 0. And we're just being asked to solve in this one. This is not written as a product, so I'm going to have to go through all of my factoring steps. First, I look for a GCF. The GCF is x. So if I pull an x out of everything in here, I'm left with x squared minus 3x minus 28 equals 0. Then I ask myself, is this a quadratic, what I have left? Yes, it is. So I can go through the rest of the process. I multiply AC. In this case, it's 1 times negative 28, which is negative 28. What multiplies to give me negative 28 and adds to give me negative 3? So that's going to be a negative 7 and a positive 4. That will do that this time. Then I can make my t-chart. My leading term goes in the top two spots. These two numbers that I just came up with go in the bottom two spots. I simplify each side. And remember, those become our two factors. So once all this work is done, you jump down to the next line. This is going to be x times x minus 7 times x plus 4 equals 0. Because this is what I get after I factor out that quadratic. And now, do I have a product set equal to 0? I absolutely do. This times this equals 0. So that means that either x has to be 0 or x minus 7 has to be 0 or x plus 4 has to be 0. I'm already done with this one. I already know that that's one of the solutions. I have to do a little bit of algebra for both of these. So I get x equals 7. And then subtract 4 from both sides. I get x equals negative 4. So this one is going to have 3 solutions. Because it only said solve, all I needed was x, because I had to solve for x. So I don't have to write these as special ordered pairs. It wasn't asking for x-intercepts this time. It was just asking for solutions. So these were the solutions. All right, one more. Let's say we have find where the function f of x equals x squared minus 9x minus 21 reaches a height of 15. Well, we talked about this in a previous video. Height is the vertical or the y direction. So they're telling me that y has to equal 15. We know that y is the same thing as f of x. So they're telling me that I have to solve 15 equals x squared minus 9x minus 21. I have a problem here. This is not going to be the zero product property unless this equals 0. Right now, this doesn't equal 0. So I first have to get the quadratic equal to 0. That's the only way that I know how to solve using the zero product property. So I'm going to have to do a little bit of algebra, subtract 15 from both sides, leaving a 0 on the left. Now I can continue with trying to use the zero product property. So I look at this quadratic. There is no GCF for me to factor out other than 1, so I can skip that step. Then I look for AC. My AC here is 1 and negative 36, which is negative 36. What multiplies to give us negative 36 and adds to give us negative 9. Again, this might take you some trials to look for all the factors, but it turns out that it's negative 12 times 3 gives you negative 36, and negative 12 plus 3 will give you negative 9. I make my t-chart. Leading term goes on the top. These two numbers paired with x go on the bottom. I simplify. And those become my two new binomials. So this will be 0 equals x minus 12 times x plus 3. And now I do have a product set equal to 0, so I can use the zero product property. Either x minus 12 equals 0 or x plus 3 equals 0. And when I solve each one, I get x equals 12 as one solution, or I get x equals negative 3 as another solution. As always, there's good news here because these are self-checkable. I should be able to take these answers, however many answers I've gotten, and plug them back into the original, so not after I've done any work, into the original problem, and make sure that the two sides balance. So I should be able to plug 12 in for x up here, and then this calculation should give me 15. I should be able to plug -3 into this side here, and that should give me 15. So these are all self-checkable, just like all algebra. You can plug it in and you can see if you get the two sides to balance. So this is the zero product property. This is why we learned how to factor. So I hope this ties everything together for you. The bottom line that I want you to take away from this is you have to pay attention to the wording of the question. If it simply says solve, then you're just looking for solutions. That was like this example. All it said was solve, and you're just looking for your x equals solutions. If the problem says find x-intercepts, then you're looking for the ordered pairs of the solutions with 0, because you're looking for the actual point where the parabola would cross the x-axis. So you want to give those as ordered pairs. Last but not least, talking about checking, you can always go to technology, plug these in, and look to see where they cross the x-axis. So if I'm looking for these x-intercepts, I can plug this into technology and find the 2 points, and that would help me verify my algebra. Or in the case of this one, I can plug the f of x into the first y. I can plug y equals 15 into the second y, graph them both, and I can see where the parabola crosses 15. And then I would look for those 2 intersection points. And these should be the 2 intersection points. So please remember that you have the technology to check as well. I hope everybody's doing well, and I will see you in the next video. Take care.